right, welcome everyone to the November edition of Ask Tom Office Hours. We're going to explore today the trace file analyzer experience, specifically talking about the service that we introduced in 18C. So with me, I have Girish Adiga, who's actually the developer in charge of this service, and I'd like to introduce him and have him introduce himself. Girish?
Thank you, Mark. Hello, everyone. My name is Girish. I work in the Applied Machine Learning group in Oracle. So I've been doing this for like last 17 years. I've been working on developing products which actually help diagnose Oracle database and GI. These tools, like you have been using these trace file analyzer, ORAchk, EXAchk tools, they have been shipping for years. So right now I'm leading the effort to develop this trace file analyzer service, which we are going to talk about in this session.
Yes, so with that, I want to let everybody know that because I have a developer on the line here, that something may be said that is future facing, and so please adhere to the safe harbor statement with regards to any information we may convey. Additionally, I want to point out that this is being recorded, and so be aware. We also are not here to be an adjunct to Oracle support services. So questions are fine, and we encourage you to ask questions, but please do not talk about specific SRs because that's not the purpose of this event. With regards to questions, I have all the lines except Girish's and mine's muted. Because this is being recorded, we ask that people ask their questions through the chat function of Zoom, and we will answer them on that basis so that they are recorded for us so that we can incorporate them in the summary of this video. So with that in mind, I'd like to kick off with, we have some participants, and so but as yet we do not have any questions. So if any of you have some early questions and want to insert them in the chat, please feel free to do so. I know this is a new feature and you might not be experienced with it yet, but we do have some questions we've already seeded, which we can start off with if no one has some initial questions. But during this session, please feel free to put in a question at any time, and we will get to it in the course of this hour. So it looks like we don't have any initial questions, so I've got one for you. What was actually Oracle's goal in developing the TFA service?
Yes, so as I mentioned in my earlier introduction, like I've been working on this team which actually develops tools for helping customers diagnose and troubleshoot issues with the database and GI. So we have been like, we have these tools, TFA Collector and ORAchk, EXAchk, and then AHF and Cluster Health Analyzer, and all these tools out there starting, like TFA initially was shipped in 11.204. So the flow was like, customers have issues, they use these tools to like do collections and then do in loco analysis on the cluster. And then if they need help, then they would go and write ASR and upload the collections. And that's where like most of the analysis used to happen. And it's kind of like deep analysis, right? We go through the logs and then understand what is going on and then provide recommendation to the customers. So now with starting like 12.2, we released this autonomous health framework, and all these are pre-configured in a centralized machine centralized server called Domain Services Cluster. So as part of that effort, we built this TFA service. The goal of the service is to actually make all these deep analysis which we do in Oracle, make them available in customer environment. So in a DSC cluster. So as we have the centralized management tools in DSC cluster, so TFA collectors will actually upload the log. So it's like centralized log management analysis for a domain services cluster environment.
Okay, well that sounds like it's a very useful function. We do have some questions. Sen asks, is TFA available on ODA, and is it licensed for standard edition? Want to address those? Because I think we'll get to those a little later, but why don't we jump into those now?
Yeah, so TFA, so we are talking about two tools here, right? One is actually TFA collector and this is TFA service. So TFA collector is available on ODA. It's actually part of the grid infrastructure. So if you actually have a GI running, then TFA installed by default on the cluster. I mean, if you have like any version of GI above 11.204, you don't need to install anything. It's installed by default, configured by default. So it is available in ODA.
And what about its licensing?
So there is no separate license for TFA. It's part of the GI license. Like if you have a database or GI license, you get it as part of the stack. There is no separate license for these tools.
Good. So Poyan asks when to use TFA and when to use IPS.
Yeah.
You want to explain the acronym?
That's a very good question. I think we started developing TFA because IPS does a very good job in collecting database diagnostics, like trace files related to that incident, right? When a database creates an incident, when it sees an exception, like ORA 600, ORA 7445, there is like list of ADR incidents for which we create a collection. Now, the main goal of TFA was to troubleshoot an issue. We need like more than just database diagnostic data, right? Like we need OS diagnostics, we need clusterware diagnostics, data from at that point in time, what was happening, right? That was I mean, if you go to if you upload this IPS to OS, that's probably the first question engineer will ask, like, can you give me OS metrics? Like, can you give me clusterware logs? So the idea behind like having TFA collector is to combine all the relevant diagnostics which is required to analyze. It includes IPS package also. So if you look at a TFA collection, it gets all the packages, all the IPS collections as part of the TFA collection. So it has like one zip which contains everything we need to troubleshoot your issue.
Mm-hmm. So we're basically augmenting the IPS function to be more comprehensive and allow less back and forth between Oracle support and the customer.
Right. And one more point I want to make here, I'm sure Bill would have covered this in TFA collector session, but we also integrate with IPS for the cluster-wide collection. So TFA, I mean, it's not like we are sitting separately. There is an integration with IPS in 12.2 to actually do a cluster-wide collection in case of a RAC database.
I see. Okay, sounds good. So how do you, turning back to the TFA service, which is actually on top of all of the collections, how do you envision its integration into operations?
Okay, so TFA service, I think the primary consumer is operations, because typically like the tools what we have, they are like specific to a cluster. So you need to log in and run commands or do a collection. The idea behind like having a centralized repository gives and a centralized centralized web page to view the collections. It provides you like across your data center, you can actually have a view across your data center, so you can see which clusters are doing good, which clusters are having exceptions. So it gives a very good view of data center wide or fleet wide health of your clusters. So that's one thing, and then second thing is like I mentioned, the more and more troubleshooting automation is put into TFA service, so it benefits the operation to quickly find out, like they'll know there is an issue without logging into the system, and then in many cases it also gives analysis saying, there is, if we know about a issue, then we can give a recommendation also.
Mm-hmm. So it basically gives people a remote insight directly into their cluster and its health. Okay, so TFA has had functionality to you mentioned about the ability to work with SRs and to work with Oracle support. Does this TFA service connect to Oracle support?
Yes, we do have that integration in TFA collector. So TFA service is actually a combination of TFA collector, and then on top of it we have a web service layer and a receiver layer. So TFA collector already has the ability to connect to the Oracle support services and then upload collections. So the same feature is available in either in TFA service, or you can also do it in on the cluster node itself. So we leverage that feature from TFA collector.
Mm-hmm. Okay. So we talk about various events that TFA collector is sensitive to and does collections. So which type of events does TFA service support?
Yes. So as part of the centralized log management, we collect all the logs. We don't just collect them and then keep them in a place, right? We also run analysis, and as part of analysis, we extract important events from the logs, and then some of them comes from the TFA collector on the machine itself, because collector also has that in loco analysis capabilities, and then at DSC node we do more analysis and create this timeline of important events. So mostly they contain like database exceptions, clusterware exceptions, and then any startup, shutdown, the state change kind of events. So you can see all of these events in a single timeline across the cluster. So you can actually easily correlate them on the timeline.
Mm-hmm. So what actions can I take when I observe these events?
Okay. So when you see these events in a timeline, first thing is we do have that view of like I mentioned, the correlated view, right? So
this is an example of such a view?
Yeah, you have this view where we aggregate it across the clusters and then provide this easily recognizable, like you can see that on the second cluster there are like abnormal events in the clusterware ASM and database. So there is something going wrong, and other clusters are kind of healthy where like there is some like warning kind of events in the database in the first cluster. The main thing is, as we capture events, we categorize them also. So some are like critical events, some are warning, some are like info events. That is something like we just let you know. And they're also in this UI, we provide them with like color coding. So as you see here with orange is kind of like you are saying, it's not a critical event, but the red ones are really critical, like some exceptions or node eviction kind of events. And when they are like aggregated at cluster level, and you can drill down by clicking on them. You see them in a timeline, and it's easy to correlate here, right? Like you can see where things are like going wrong, and then you can click on individual event and then go to that clusters. Yeah, here, I mean, on highlight, we tell there is a instance termination, and if you click on that, you can actually go to the actual log file where it is highlighted where that error, yeah, where we saw that error. And it also gives the relevant chunk of the log, so you can find the root cause of the problem, quickly find the root cause of the problem. And then there are also other interesting things we do, like you can correlate it with the OS metrics, so you can easily see if there is some spike in OS metrics causing this problem. So yeah, so it's kind of like from the event you can drill down to the logs and correlate them easily with few clicks.
So basically, I don't have to go searching for logs in the ADR and all my nodes. It's all here. It's all indexed. It's all laid out, and it's all annotated, so that I can efficiently go directly to the relevant incident entries.
Right.
Well, that looks very useful. So based on that, can I get alerted to these events to go look for them?
Yes. So we, again, the TFA collector, we use the same alerting capabilities what we have in TFA collector. We already have the notification framework in TFA where you can set your email address, and then you get notified on these critical events. So you can actually directly jump to the TFA. I mean, you don't have to like stare on the screen, right? Instead, you can get alerted and then come to this page and click and go to the exact event in the log.
I see. So you also mentioned this concept of, I mean, we've got these events, and in the introduction, you also mentioned anomalies. What is actually considered an anomaly?
Yeah. So as we started automating this troubleshooting, like, there are thousands of patterns in log files, right? So it's very hard to, especially in a distributed stack where you have like hundreds of components, and then they write log lines in their trace files, and then there is OS and other like network and other components on which the stack depends on. So a database issue can be actually caused by a clusterware, some issue in clusterware, or like a node eviction or instance eviction could be caused by some network glitch. So the interesting thing about these log files which are written by software is like, it's not just important. Obviously, there will be something where it says CSS cannot communicate to other node because of a network issue, but that it's a needle in a haystack problem, right? The CSS log file is like 50 MB of logs, and then you have database alert log, which is like, maybe 10 MB. Like that, you have like, if you get a issue, the log, even if you use TFA collector to trim down your collection, it is still like 1 GB of data. I mean, it can be like several MBs of data, right? So to find that needle in the haystack is kind of like a difficult problem. And we started addressing this problem by using machine learning methodologies to actually find what are those interesting log lines which are printed only during the errors, right? I mean, that's the anomaly part here. So anomaly is something which is not printed, which you don't see always. So if you take like a collection of log files and then you go through them, lot of those lines you recognize them, like starting a process with some PID. That line gets printed, like in every alert log you see that line. But something like ORAchk 600 foo, it won't be printed in every alert log, right? I mean, it will be only seen when there is an exception. And these are important lines which actually give a clue about these errors. So anomaly is something which is it's that needle in the haystack where out of this MBs of logs, the log lines which are printed only during an exception is actually considered anomalous lines, anomalous log lines.
Okay, so how do I know whether an anomaly is benign, good, bad? Because exceptions don't. There are exceptions, but I'm sure there are other types of anomalous entries.
Yes. So that's a good point, Mark. Like there are exceptions. I can easily find, I can do a grep saying grep for ORAchk 600 in my alert log. And I know all the exceptions. I don't need machine learning or anomaly detection for that. But before that exception, things like the case I mentioned, there is a network glitch and CSS, on CSS logs, you just see something like it cannot connect to the other node. I mean, there will be lines, log lines printed by the software, which are like, very cryptic. They are probably developer friendly. They don't necessarily like an exception in the log file. And then finally, it leads to that ORAchk 600. So in such cases, this is where we need to identify, like, out of, say, let's say this is like 50 MB of log file. We are only interested in those two lines. There is some network error printed in CSS, and there is a termination in the database alert log. These are the only two lines which we are interested. So the way we do this is actually we look at, like, from in our lab, we actually collect a lot of this log data over our development cycle. So we collect like terabytes of logs during the development life cycle, and then we apply machine learning to identify which are lines which are actually happening only when there is an exception, or which are log lines which get printed like rarely, and they are only printed when there is an exception. And we build these models in our labs, so and then it gets shipped as part of the TFA service. So on your cluster, like on your DSC where TFA service is running, it's actually taking those models which we built in our lab and then running them against the logs from your clusters, and then it identifies those lines which our model already marked them as like good or bad. That job is already done for you in our lab. So it runs that on the collected logs and finds out the anomalous lines. I mean, in many cases, it's like from that millions of lines, we can get you that chunk of logs which are like only related to that exception. So it uses, I mean, mostly the machine learning models to identify it's a good or bad pattern.
So basically, the subject matter experts in development have already pre-identified these anomalous lines as bad, and therefore I don't have to further determine that myself as an admin.
Correct.
I see. So how would I make best way to make use of this anomaly timeline?
So the anomaly timeline is integrated into TFA service. So as part of the analysis, say an exception happens in your cluster, and the TFA does a collection, and then the collection gets uploaded to a centralized TFA service running in DSC. We do like all this anomaly detection based analysis in the TFA service, and when you actually browse that event, you will get an anomaly timeline which you're looking at in the screen, like it's a instance crash with ORA 29770. The interesting thing here is actually this collection had like 3 GB of log files, and it's like it had database logs, clusterware logs, and then all the logs, relevant logs from all the components. But if you see the relevant timeline section, it's probably like 10 lines of log data across like database trace files, like database alert log, LMH trace files. All the relevant log lines are actually presented in that anomaly timeline. So, I mean, that's the power of anomaly timeline. And it gives you like a condensed view, just the chunks of log which are interesting for that error. So you can, like, you don't need to browse through the pages of log file. You can just quickly look at these 10 lines, and there you have your error, and it also has all the relevant information what led to that error. You can actually click and go to the little bit more verbose from these errors, and there it gives you a little bit more details. Like in this case, it may give you saying there is some CPU spike and then it led to a instance crash. So it's very much integrated into the UI. Yeah, this shows like the way you can. You can click on in the home page. You have a option to see the timeline, and then you can click and go to the timeline then and there. So,
okay, that sounds quite efficient to be able to triage issues that I may get alerted on. Okay, so this obviously looks like a very valuable service, but how do I get it? I mean, you mentioned
yes.
You've been mentioning the DSC or Domain Service Cluster a bit.
Yes.
Can you address that?
Yes. So you don't need to actually do anything. If you set up a 18C Domain Services Cluster, you get it as part of the DSC setup. So TFA Service is integrated into the credential generation and member cluster creation. So TFA Service will be running configured and run by default on a DSC server, and then it configures a data store on a CFS file system repository, and then it pre-configures everything. Like all the member clusters are configured by default to talk to this TFA service. So by the time, once you have your 18C DSC set up with all the member clusters, it's all up and running for you. So you don't need to get anything, or you don't need to configure anything.
Yeah, so for those of you who are maybe coming from 12.1 or just introduced to 12.2, there is a new installation type in 12 that were introduced in 12.2 as part of the installer, which is what he's addressing, the Domain Services Cluster. And that's a way to centralize all of the services that are basically diagnostic in nature and move the management repositories into a centralized location, as well as the TFA repository, and have these daemons pointed to that cluster instead of storing all the information locally. So it makes for a much more streamlined and efficient management model. And that was introduced in 12.2, and we're building on it, obviously, in 18. So we have another question. So in 18C DSC, is TFA different from the standalone TFA that I download from Oracle? And if so, how do I upgrade the DSC TFA? Is it just simply part of the GI upload?
Yes. So the DSC TFA, to make that point clear, actually the TFA itself is actually a single installer, like in the sense I mentioned this earlier also, TFA Service is part of the collector. So it's actually if you look at the stack, it's actually TFA collector. And on top of it, we have TFA Service and a web service layer. So, but you don't have you don't have that in the standalone TFA as of today. So you have to actually set up DSC, so you have to upgrade GI, the DSC GI to 18C. That's how TFA also gets upgraded to the DSC with the TFA service feature in your DSC.
So if I understand you correctly, once you have an 18C DSC, I can continue to upgrade the TFA portion using the normal methods, and it will still maintain that functionality. I don't need to actually wait till I do a GI upgrade to improve my TFA experience.
Yes. So, I mean, to make my point clear, you have to have that 18C. If you are like on a 12.2 DSC, you have to upgrade to 18C DSC, the GI. Yeah. So once you do that, then you can upgrade TFA. If you have 12.2 and if you download like MOS TFA, then you may not. We will not create a. We will not stand up a TFA service on a 12.2 DSC cluster. So
okay.
18C is kind of like a.
So my first step is to create or upgrade to an 18C DSC, and that auto provisions this service. And then if I want to download 18.3 or 18.4 TFA to my DSC, I'll still maintain that service.
Correct.
Yeah. So a follow-up question was, so if we upgrade GI to 18.x, will TFA be upgraded as well, or do we have to upgrade TFA additionally?
So TFA will be upgraded automatically. So whatever the 18C GI, the TFA in 18C GI already has the TFA service installer. So if you upgrade GI, it automatically detects that this is a DSC cluster, and it stands up the TFA service and the web and the web part. So we mentioned about upgrading TFA because we release quarterly TFA on MOS. So if you wish to upgrade to latest TFA, you could upgrade once you are on 18C DSC. Then incrementally you can take new TFA and then upgrade just the TFA bit. So just to clear that point. So
sure.
To get the TFA service, the requirement is you need 18C GI and DSC. After that, you can upgrade to like 18.4 TFA in your 18C DSC cluster.
Okay. So you mentioned that we had to have 18.3 in the DSC to take advantage of this service. But do I need to have 18.3 everywhere to be able to populate this, the repository, or can I work with older databases or older grid infrastructures?
It works with, older version of database in GI. So it's basically the same TFA collector which you are running, which you're downloading and running in your clusters. So you don't need 18.3 in all your other clusters. You can have but you do need the latest TFA on those clusters to actually be able to connect to the DSC cluster. You don't need to upgrade database in GI to use this.
Okay, so you're saying I should go and upgrade my local installations on my member clusters to 18 TFA, but that's a standalone upgrade without needing to upgrade the GI. Is that what you're saying?
And even, database also, it will work with like 11.2 database, or even the older databases. Okay,
so basically all of the components need to be a consistent version, but I don't need the infrastructure that they're monitoring doesn't need to be at that level.
Right.
Okay. Can I get this functionality? I think we addressed this a bit, but is it safe to always assume that I can get this functionality out of the latest MOS version.
Yes, that's correct. So, I mean, we always tell customers to upgrade to the latest version of TFAs because we add a lot of new diagnostics and new features into TFA. So it's always good to get the latest version from MOS and upgrade the TFA. And it will, once you have, as I mentioned, once you have 18C DSC, you can safely keep upgrading your TFA on DSC and member clusters to get all these new features.
Mm-hmm. And so this is the MOS note that I need to sync to. Okay. So you talked a little bit about configurations. Do I actually need to go through any steps after I've done the upgrade or installation to get TFA working between its member clusters and the centralized service?
So, as I mentioned earlier, there is no manual configuration required to connect like TFA service, member clusters. All of that is integrated as part of your member cluster creation framework. The credentials, all of that gets exported as part of the member cluster creation and TFA service. The TFA collectors running in member cluster automatically connect to TFA service. So it's provisioned by default. And all the configuration on TFA service also happens by default without, there is no human steps there, except for there is one step which you need to do. When after you are done all the setup, you can go to the UI and it will actually, on the UI itself, it will say, run this command to choose a password. So the UI actually has you need to actually select a password for accessing the UI. For that, as an admin user in TFA service on one of the nodes in the cluster, you have to run this command to, the exact command is also printed on the screen when you go to that link. So it will say, run this command to choose a password. So once you run that as the admin user in your TFA service on the machine, then you can go back to the UI and log in and view the same page what Mark showed earlier, which lists all the clusters and then events.
So we have an additional question here. Does the TFA that the DSC supports have a UI? And it looked like it was a browser. Is that correct? And are there any specific browsers we need to support or plugins that need to be added?
So TFA service, to answer the question, TFA service does have a UI, and it runs the web service runs on the DSC machine, so you can actually go to the DSC machine. There is a command called TFA CTL receiver info. If you type that command, it will give you the exact URL to copy paste to your browser. So it is actually there is a web server running on your DSC machine, and it shows the UI is what Mark showed earlier in the where we had like all those color coded list of clusters and the color coded component health. And this is completely developed in Oracle Jet, so it doesn't have any like specific browser or plugin requirement. It should work. You just copy paste. Yeah.
It looks like this here.
Yeah, it looks like this.
So there seemed to be a bit of confusion out there. People were thinking that this was an Oracle Cloud offering, but in fact, it's actually hosted on premise by the actual DSC, correct?
Right. Yeah. It's the web server also runs on the DSC, so you could go to the UI in your DSC machine itself.
So So basically, the URL will be the node name of my
correct
DSC.
Yeah.
And a particular port number.
Correct. You don't need any cloud account or any of that. It's all running in your machine, and there's nothing. Yeah.
Yeah. So somebody says this is like EXpress. Yes, in the sense that it is hosted locally without actually, but it's actually not hosted. EXpress is hosted locally to the node it's monitoring.
Yeah.
Where this is actually more like EM Cloud Control in that it is hosted outside the cluster that it's monitoring, and everybody is pointing to it to deposit information.
Okay. And it gives you like all the member clusters, right? View across all your member clusters. So it's kind of like it's a cloud kind of service for your data center. It's running in your data center, giving you bird's eye view of your cluster.
So I don't need any additional plugins then.
Correct. No plugins, no browser requirements.
Okay. So you mentioned about configuring a password and I assume a particular user. So is there specific users that I need, a username or a group of users? Who can access this?
Yeah. So currently it's we just have one admin user. So it's not open to all. So you have to configure a admin user. So that's the password you choose when you actually run that command as part of the post installation configuration. So once you have that, then you can log in as the admin user. So the admin user will have access to all the events across all the clusters. So there is we don't have that specific roles or multiple users with specific access to specific clusters. Right now it requires authentication, and then there is one user who has access to the complete all the members.
Okay, so that one user can see the logs from all of the clusters that are member clusters associated with that DSC.
Right.
Yeah, I see. Okay, so look, you mentioned that this is a repository for all these logs and collections from the various member clusters. Is there a lifecycle management function built into this system?
Right. So TFA Service takes care of lifecycle management of the repository. So when we say repository, it's a ACFS file system we create to store all the logs from like all the member clusters and then process them. Even analysis data is stored in the repository. So all of this is automatic. Like you don't need to do any of the lifecycle management of the log data. So the only thing is you can configure how many days of data you want. Like even that, if you actually say I want like 1 week of data, and then the repository gets full, then the collector itself understands that the quota is full. It keeps like till you go ahead and clear some things manually. The only manual requirement if you have like too many collections and then in a day, and then you can't if that quota becomes full for that cluster, that's when you may need to go and clear some collections manually. But if you have enough space, or you could also extend the ACFS file system size if repository becomes full.
So you mentioned ACFS file system. So this repository is not hosted on the local file system or file shares associated with the DSC. It's actually in shared storage, just like my database files would be. So it's in a disk group.
Right. It's on a ACFS file system.
I see. Okay. So I mentioned earlier that this is sort of similar to Enterprise Manager from a standpoint of its centralization. Is there any integration into Enterprise Manager at this time?
Right now, there is no integration with the Enterprise Manager. It's actually a standalone UI, right? So it's like it has there is a purpose for this tool, like it's a centralized log analytics kind of solution on-prem. So there's no integration with the Enterprise Manager at this point in time.
I see. Okay. How about integration with other tools that get shipped with TFA, such as ORAchk and EXAchk, et cetera?
Yes. So this is again a good question, because when we started building this, the main focus was to get this log analysis, and basically any collection from the clusters get pushed to this centralized repository, and then you have a UI where you can see not just the logs, but analysis and logs. Now, again, with the EXAchk, ORAchk also, you could, today, we have the capability to view the logs, view the EXAchk reports in a central repository. But there is more. I mean, we are actively working on doing like more analytics on top of data from ORAchk and EXAchk and all these AHF tools, right? Autonomous Health Framework tools. So there will be more integration, and not just integration, like the analysis part will be rich with more information from all these tools. So you will see, like in coming releases, you will see a dashboard with where you can slice and dice ORAchk data, which failures are trending, and you can slice and dice the health score by various clusters and components within the clusters. So that's something which we are actively working on. But today you do have the capability to view the ORAchk reports in this.
So there's a further integration question. Is there any plan to integrate with DBSAT?
So I'm not 100% sure about this question, but I mean, the DBSAT there is an integration plan, or it's already integrated in ORAchk. So the TFA service, because we already integrate with ORAchk, it should, I mean, you will get it, but I mean, this is a question. I'm not sure about that integration is done or not.
So the question is the nature of the integration so ORAchk is already getting this information into the reports, right?
Right.
And it's a question of, are we going to do further analysis based on that? That's what you're saying?
Right. Yeah. I mean, the features we are working on, like I mentioned, not just viewing the ORAchk reports, but to actually capture the data which ORAchk and EXAchk are gathering, and then provide like analytics on top of it. So it will have rich integration with the data from ORAchk, EXAchk, not just the reports.
I see. Okay. So this was already addressed, but just to clarify, not only TFA, but the DSC portion of the TFA service, does it require any packs or any special Oracle license or options to make use of it?
No. The simple answer is no. I mean, TFA service is part of DSC. So if you set up DSC, it's even configured by default. So there is nothing extra you pay for.
Right. So just to clarify, the DSC is considered an infrastructure cluster, and much like the Grid Infrastructure Management repository, which is an Oracle database, but is one that you don't need a specific license for. The whole domain services cluster, basically, as long as it's monitoring Oracle software stack, which is its intended use in these member clusters, the actual infrastructure cluster doesn't require paid licenses for the components that reside there, such as the database, ACFS file system, etc. So you touched on this a little bit already, but can you expand a little bit on how you see integration with other AHF components with this TFA service?
Yes. So right now we are actively working. I mean, these are some of the features we are actively working on. We started with log aggregation. Now we already have like EXAchk has set of tools which are doing like particular targeted troubleshooting or health of the cluster. So like CHA and QoS and EXAchk, ORAchk, and I mean all these tools are actually doing their job in the clusters. So I mean they're already there and running and doing analysis, and you have ability to query them. And we started integrating these tools, and there is the integration with TFA collector and CHA where you can get notification, do collection. So that immediately, like TFA service gets benefit from that, because now with CHA events you get TFA collections, and then TFA service gets those collections, and then you can see the results. But with the, I mean, currently the integration we are working on is something where there will be a tighter integration with the data from all these tools. You'll be able to see kind of like near real time on this UI.
Mm-hmm.
So like data from CHA or QoS will be integrated into the TFA service.
I see. Oh, that sounds very promising.